Hello and welcome to the Chem Solver. Today we are using the IUPAC Nomenclature Simulator, a drawing tool where you build organic molecules by hand and watch the systematic name update in real time. This is one of the best ways to build intuition for how structure and name connect. Because you are not just reading a name, you are constructing the molecule atom by atom and bond by bond. So yeah, let us walk through it together. The canvas is blank when you start. On the left you have a palette of tools. The chain tool lets you extend a carbon chain. The bond tools let you place single, double or triple bonds. Ring tools give you pre-built rings like benzene, cyclohexane, cyclopentane, cyclobutane and cyclopropane. You also have a substituent palette with common groups like halogens, hydroxyl, amino, carboxyl and alkyl groups. The naming panel on the right shows the IUPAC name updating live. Let us draw simple molecule butane. Select the chain tool. Click once on the canvas to place the first carbon. Click adjacent positions 3 more times to extend the chain to 4 carbons. The naming panel immediately reads butane. 4 carbons in a linear chain, no branches, no functional groups, alkane suffix. The name has 2 parts, but for 4 carbons and ane for a saturated acyclic compound. Now let us add a branch. Select the methyl substituent from the palette. Click on the second carbon in the chain. A CH3 group attaches. The naming panel updates to 2-methyl butane. The longest chain is still 4 carbons, so the parent is butane. The methyl branch is at carbon 2, numbered from the end that gives the lowest locant to the substituent. If you had clicked on the carbon 3 instead, the name would still be 2-methyl butane by symmetry, always numbered from the closer end. Now let us modify a bond. Select the double bond tool from the palette. Click the bond between carbon 2 and carbon 3. The single bond becomes a double bond. The naming panel updates the update to show the corresponding alkene name. The suffix changes from ane to ene. The locant of the double bond is inserted. The name reflects where the double bond begins. The branch locant may shift as well because IUPAC rules give priority to the principal characteristic group when assigning numbering. Toggle the numbering display on using numbering button in the toolbar. You will see small numbers appear next to each carbon in the structure. This makes it easy to verify that your locants in the name matches the position in the structure. Use this toggle whenever you are unsure whether a name is correct. Now clear the canvas and try an aromatic compound. Select the benzene ring tool and click it to place it. The naming panel reads benzene immediately. Now select the chain tool and drag from one of the rings to add a single carbon. The name updates to toluene or methylbenzene. Click the highlighting toggle to see the parent chain highlighted a different color, separate from the ring system. This is especially useful when you are working with larger molecules where identifying the longest chain or the principal ring system requires careful inspection. The substituent tools work the same way for functional groups. place an OH group on the carbon and the suffix changes from ane to ol for an alcohol. Place a COH group and the suffix becomes oic acid. The simulator handles the priority rules automatically. When multiple functional groups are present, the highest priority group determines the principal suffix and lower priority groups are listed as prefixes. For ring systems, try fusing a second ring. Select the ring tool and drag from a bond on the existing benzene ring to attach a new ring. The simulator recognizes the fused bicyclic system and applies the appropriate naming rules. Try the Spiro tool to attach a ring at a single shared carbon. The name will include the Spiro prefix and the ring size descriptors. The IUPAC naming rules are a systematic language. Every structural feature, chain length, branching, unsaturation, functional groups, ring systems, stereochemistry maps to a specific part of the name. The simulator makes that mapping visible and interactive. Draw a molecule, read its name, then try to predict what would change if you added one more carbon or change the bond order. Check your prediction by making this edit. The cycle of predict, draw and verify is how you build deep fluency in nomenclature. Try this simulation for free at chemsolver.com. The link is in the description. If you have any questions, drop them in the comments. We read every one. See you in the next video.